Right. So, hi friends. Uh, in this session, I'll be discussing about the topic that is radiology. Okay, I'll be discussing in detail, uh, mostly concentrating on the important points what we come across in the exams. Okay, so let's go with the first important aspect. The first important aspect is radiology here. And what is radiology, guys? Radiology is energy that comes from a source and travels through some material or space. So what is the important point which we need to understand is radiation. So right, what is radiation? Radiation is energy that comes from a source, right? It is coming from a source and it is traveling through some material or space. And what do you mean by radiation here? Radiation is energy that moves from one place to another in a form that can be in the form of waves or the particles. Okay, we'll be discussing about from where does it travel, okay, and what happens. We'll be discussing about the cathode and the anode. That's all secondary, but timing you just understand is coming radiation. It is an energy which is coming from a source and it is passing through a material space. Enough, right? Now, under these radiations, you have ionizing radiations and the non-ionizing radiation, right? You have ionizing radiations, non-ionizing radiations. What do you mean by ionizing radiation? What do you mean by non-ionizing radiation? The first point which we need to understand regarding the ionizing radiation. The name itself tells ionizing means which ionizes a matter, right? Which ionizes a matter. What is a non-ionizing? Which cannot ionize a matter. Okay, so what exactly the ionizing means? It is a process by which electrically neutral atom, right? Electrically neutral atom with electrically charged atom either through gaining or losing electrons. Now, this radiations, right? The ionizing radiations, they have the ability to electrically charge the atoms, right? These radiations either they take the electrons or they give the electrons so that the charge, right, it becomes a charged atom. And the next important aspect is non-ionizing. What do you mean by non-ionizing? Non-ionizing is which can't ionize a matter, right? Which can't ionize a matter. We'll be discussing about what are the examples of the ionizing and what are non-ionizing agents. So it's written here what are non-ionizing and what are ionizing agents or the non-ionizing examples. Okay, under this it's written that you have an X-ray, right? Alpha, beta, gamma. The X-rays, alpha, beta, gamma, they all are the examples of ionizing agents. What comes under non-ionizing agents here? This is UV rays, visible light, IR rays, microwaves, radio waves. Now these can be understood only when you know what is electromagnetic spectrum. Okay, so this is an electromagnetic spectrum. When I talk about this electromagnetic spectrum, okay, when I talk about the electromagnetic spectrum, we need to understand, right? We need to understand you have something known as a low frequency here and you got a high frequency. When I tell this is a low frequency, when I tell this is a high frequency, one thing you need to understand, you have a different rays here. Okay, the one which come under the ionizing radiations are X-ray, gamma and the cosmic.
Adios, amigo.
The one which comes under the non-ionizing radiations, if you observe carefully, ultraviolet, visible, infrared, microwaves, and the radio waves. Okay, so these are the important points, right? IMR, infant mortality rate, UV, right? UV. So you can just remember like that. So these are the most important points which you need to understand. And the next important thing which we need to understand is, now under this ionizing, what exactly it means is, this ionizing radiations, right? Under the ionizing radiations, we have the electromagnetic, right? Under the electromagnetic, ionizing comes under the X-ray, then the gamma rays. Okay, comes under the X-rays and the gamma rays. Now, under the particulate, you have an electron, proton, and neutrons. Electron, protons, or neutrons. That's the basic point. Okay. Now, these ionizing radiations have got, if you look into this, they have got a short wavelength. If you look into this, they have got a short wavelength. There is increasing energy, and they have got an increased frequency. When I tell you have got an increased frequency, when I tell you have got an increased energy, right? Increased frequency, you have got an increased energy, right? Increased frequency, increased energy. That is, you have got a wavelength, short wavelength. Okay, you got a short wavelength. Now, if you look into the non-ionizing examples, they have got a long wavelength. Remember, they have got a long wavelength. Once there is a long wavelength, you need to understand low frequency. Okay, and you got a low energy. These are the basic points you need to understand. Okay, let us look into the next important aspect. The next important aspect written here, it is a radiotherapy. Remember, what do you mean by radiotherapy? We spoke about the radiations just now. Now it's time to understand regarding radiotherapy. What do you mean by that? Okay. Now, the use of high energy radiations. What are high energy radiation which we need to understand? We need to understand the high energy radiations are these ionizing radiations. This high energy radiation, that is an ionizing radiations to kill the cell, right? Radiotherapy, right? Radiotherapy is use of high energy radiation form to kill the cells, right? Now, what can be used for the ionizing radiations? You have an alpha, beta, gamma, X-ray. They can be used for the radiotherapy. Now, let us speak about the non-ionizing radiation. It's written, type of low energy radiation that does not have enough energy to remove an electron from the atom or molecule. So since it is a low energy, it doesn't have that energy to remove, okay, that energy to remove the electrons, right? To remove the electron, right, from the atom or the molecule. That's the point. Let us look into the next important aspect here. The next important aspect is, one is a difference between electromagnetic radiation, right? Electromagnetic radiations, difference between. Now, you need to understand, in a whole of the electromagnetic spectrum which I have shown you, you have something common and some are different. Now, we need to understand, right? There is an frequency, increased energy, decreased wavelength, right? Increased frequency, right? Increased energy, increased wavelength. So you observe the spectrum here. Now, this has got a high frequency. As we come toward the right side, there is a low frequency. When I tell this is a low frequency, then you need to understand it's a low energy and high wavelength. Okay, high wavelength. So that's the basic points. Okay. And the next important aspect is when I tell you the frequency increased, okay, energy increases and the wavelength decreases. The next important points, that is the common features between different electromagnetic radiations. What are the common features between different electromagnetic radiations? The common features are, right? The common features are, you have one is a velocity, you have no mass, and you got no charge. These electromagnetic radiations, they have got a common velocity. What is the velocity? The velocity of an electromagnetic radiation is 3 into 10 to the power 8 meter per second. And we should also understand, and there is no mass for these electromagnetic radiations. And we should also understand there is no charge for the electromagnetic radiations. So ultimately, you need to understand the electromagnetic radiations, they are packet of energy. Understand? These are the packet of energy. And these are the packet of energy is nothing but it is photons. That is photons. Okay? Packet of energy, that is photons. That's all you need to understand in this point. Now, let us look into the next important points. The next important points are, which of the following can be used in photon based radiotherapy? They have given the question, which of the following can be used in photon based radiotherapy? The first thing is, you have X-rays, alpha, beta, gamma. The two important points which can be used in the photon based radiotherapy, that is alpha, beta. It's a wrong answer. It is only the X-ray and the gamma. If you look into this electromagnetic spectrum here, right? If you look into the spectrum, you have X-rays and the gammas. These X-ray and the gamma, they are used in the photon, right? They are used in the photon based radiotherapy. Right? They are non-photon. So alpha and beta they are not photons. Okay.